Hey everyone, welcome to this explainer. Look, we've all seen the crazy headlines about the 2026 AI boom, right? But behind your screen, far away from the slick chat interfaces and the endless lines of code, there lies a hidden, massive, and incredibly physical reality. Today, we're stepping right inside the AI power grid to unroll the technical secrets of the 21st century's absolute most vital infrastructure. Let's dive into it.
So what actually happens when the infinite virtual world of software literally slams into the hard, uncompromising limits of concrete, copper, and raw electricity? I mean, we've spent years obsessing over which lab has the smartest algorithms, but honestly, that narrative is officially outdated. The true bottleneck for human progress is no longer computing logic, it's physical energy.
To really wrap our heads around the sheer, world-altering scale of this shift, just look at this number. $965 billion. That was Anthropic's staggering post-money valuation back in May 2026, making them the most valuable pure-play AI firm on the entire planet. This isn't just some bloated software valuation anymore. This positions them as foundational utility providers. We're talking comparable to the great telecommunications networks or the railway barons of the past. But what exactly is driving all this trillion-dollar hype?
Well, let's be real. The enterprise world has completely moved on from simple chatbots. Now, it's all about multi-agent systems, or MAS. Instead of just one AI trying to juggle everything, you've got networks of highly specialized AI agents coordinating entirely autonomously. Think of it like a massive digital factory where these agents break down a huge problem, assign specific roles, and execute multi-step workflows without a human needing to hold their hand every single second.
And the impact? It's absolutely immediate. If we look at the data from McKinsey, we're seeing massive productivity gains in notoriously slow sectors, like modernizing legacy insurance systems. I mean, we are seeing testing and defect compression speed up by up to 90%. Agents are independently reverse engineering decades-old code, translating it into plain English, and executing test suites. They're literally doing in days what used to take specialized teams months or even years.
But of course, you can't just let these agents run wild. Putting this into production requires some serious guardrails, because these agents can take actual real-world actions like editing live databases or issuing financial refunds. Best practices now demand capping them at just 5 to 8 whitelisted tools to prevent them from getting confused. Enterprises are strictly budgeting agent actions, they're capping API spend, and they're requiring non-negotiable human-in-the-loop checkpoints for any irreversible action.
Now this brings us to the actual models powering these systems. And honestly, it's a fascinating battle between two totally different philosophies. On one side, we have Google's Gemini 3.5 Flash, which is optimized for blistering speed and low latency. And on the other, you've got Anthropic's Claude Opus 4.7, built for deep reasoning and highly reliable execution. So, who wins? The answer is completely reshaping how developers build right now.
Well, the answer lies in this really surprising phenomenon called the tier inversion. Actually, scratch what we used to think. Smaller, speed-optimized models are now beating the massive flagship models at agentic tasks. Gemini 3.5 Flash scored an 83.6% on the MCP Atlas tool use benchmark, essentially leaving the larger, slower models in the dust. Why? Because in multi-step workflows, speed compounds. If an agent has to check a condition, make a decision, and act dozens of times a minute, a faster model simply doesn't break the flow.
Okay, but let's pause and pivot sharply here for a second. Because whether you're using a blazing fast model or a deep reasoning model, you've got millions of enterprise agents firing off literally billions of requests, which begs the million-dollar question, where does all this processing power actually live? Because it's not just floating in the cloud. It lives in heavy, massive, terrestrial infrastructure.
It turns out we've completely moved away from traditional data centers. We have officially entered the era of the AI Superfactory. You can kind of think of the 14th century Venetian arsenal, the world's first industrial assembly line. Well, today's AI superfactories are exactly that, highly integrated leviathans where the architecture, the electrical grid, and the cooling systems are co-optimized as a single breathing organism. And it's all designed for one thing: extreme compute density.
To put that into perspective, just take a look inside Microsoft's Fairwater superfactories. The physical metrics here are simply mind-blowing. We're talking 140 kilowatts of power packed into a single rack. They use closed-loop liquid cooling with zero evaporation. There's an 800-volt DC power architecture in place just to manage the synchronized electrical spikes. And to connect all of this together, 120,000 miles of dedicated AI fiber optic cables. No big deal, right?
Now, this push for extreme density has actually fractured the industry into two totally competing physical architectures.
First, you've got the centralized mega-campus approach, like Fairwater, which concentrates hundreds of thousands of GPUs in these massive multi-100-megawatt hubs. But contrasting that is the distributed network approach, like Europe's Digital Energy Group. They link smaller 5 to 20 megawatt nodes using lossless Ethernet over dark fiber, which is essentially a genius way of tricking the GPUs into thinking they're all sitting in the exact same room.
But, regardless of which architecture wins out, you still hit a rather terrifying bottleneck. The true war for the future, it isn't happening in lines of code anymore. It has moved straight to high-voltage power lines. Right now, tech giants are fighting the actual speed of light, and even more importantly, they are fighting for the sheer availability of raw electrical power.
And this insatiable demand for power, it is triggering some historic macroeconomic earthquakes. I mean, look no further than the massive $66.8 billion merger between NextEra and Dominion Energy back in May 2026. Make no mistake, this was not a tech acquisition. This was a pure energy and utility consolidation, and it instantly created the world's largest regulated utility with 110 gigawatts of generation capacity.
So the way this utility behemoth shook out is pretty interesting. It split up with NextEra legacy shareholders holding exactly 74.5% and Dominion shareholders keeping the remaining 25.5%. This massive entity now completely controls the electrical grid for 10 million accounts across the American Southeast. Because here's the thing. NextEra isn't just buying up customers. They're buying the actual physical grid infrastructure required to support the data centers that are just exploding across regions like Northern Virginia.
And that massive consolidation brings us right to a really fierce regulatory battleground over at the Virginia State Corporation Commission. Regulators are stuck in the middle, being forced to decide who actually foots the bill for this multi-billion-dollar grid expansion that the tech hyperscalers are demanding. Consumer advocates are stepping in, demanding structural ring fencing. Basically, they want to ensure that everyday residential households don't end up subsidizing the massive, unprecedented energy upgrades required by these trillion-dollar AI companies.
So what does this all mean for us? Well, this corporate war for megawatts is creating some serious systemic ripples across the entire economy. By mid-2026, inflation actually accelerated to 4.25%, and that was driven heavily by an 18% spike in energy costs alone. Consequently, the consumer savings rate plummeted to just 3.6%. The staggering capital requirements needed for this AI grid are literally directly impacting household utility bills and squeezing consumer financial stability.
At the end of the day, it really all boils down to a reality that industry insiders have summed up perfectly. Megawatts have become the new gunpowder. Let that sink in for a second. In the race to build the next generation of multi-agent systems and ultimately achieve artificial general intelligence, the victor won't just be the guy with the best software. It's going to be the one who can secure, manage, and sustain the most raw physical energy. Which ultimately leaves us with one very profound kinda lingering question. Can humanity actually build a sustainable grid before the exponential demands of AI consume our energy supply entirely? The virtual future we are coding right now has a very real, very heavy physical cost. Keep that in mind the next time a shiny new AI model drops. Thanks so much for joining this explainer.